So the easiest way to do this one is to look at the full area first. So this big area right here, well, that area right there would be 14 times 11. I guess that would be area 1. Area 1 would be 14 times 11 with 140 would be 154. Then what I want to do is I want to calculate this little area right here. Well, that little area is 7 times 7. So let's call that area 2. Area 2 would be 7 times 7, which equals 49. My shaded area, shade A, is going to be the big area minus the small area, which is going to equal 105. 105 feet squared. Most of us got it right. There was 2 that got it wrong, so make sure you know how to do that. That's important that you know how to do this one. Our next one is similar to that walkway problem, where you have a walkway around a garden, you have a walkway around a pool. This is important in math. It shows up a lot. So the first thing I would do is I'd calculate our total area. Calculate that total area. So total area would equal 10.8 times 27. What does that equal? I don't have that offhand. Well, 270. What is that? Someone has it. Yes. Yeah. 291.6. All right, then we're going to do that small area, so just that white area. So let's just call that our small area. Our small area is going to equal 9 times 19.8. And what does that one result in? Aryan? 178.2. All right, to get the shaded area, we just have to do the big area, which is 291.6, and subtract away 178.2. And what is my end area going to be? Yes? Yeah, I got to do a little bit more room. 93.4 centimeters squared. All right, questions on either one of those bell work problems? Oh, was it 93.4? 113.4. You had the 0.4 and the 3. We should have got 113.4 centimeters squared. Yeah, 113.4 works out. All right, questions on the bell work, Sam? No. Okay. Questions on the homework? Yes, Grant? 30. So we're not going to spend a ton of time on it. I think I did a pretty good job explaining it on my answer key. I did show all of the steps, so we're just going to talk about them. So it's not... maybe we'll just do 27 too. But 30 is... So the first thing is it is not showing up. Ton of time on this. So number 30, your job was to find the area of this, which means I need the base and I need the height. Well, we can't get much out of this. What we can get is if I go straight across and draw my heights like I did here and here, I know that distance across from here is 10, so I have this distance as 10, which leaves 14 to spread out between these two sides. Well, since it's not isosceles, I can't just make it 7 and 7. It's going to be a different number. So I have to make one is x and one is 14 minus x. Well, then I'm going to treat these as I normally would. I would treat them as right triangles where we have a squared plus b squared equals c squared. So for this first triangle, it would be h squared plus x squared equals 13 squared. For the other one, there is a mistake on here. It shouldn't be 24. It should have been 14. That should have been 14. So it should have been h squared plus 14 minus x squared equals 15 squared. Well, these are just two equations with two variables. I don't care how you solve it. Substitution or elimination would have worked also. We could have just used subtraction and got rid of those h's as well. I used substitution, so I said, well, solve for h squared. So I solved for h squared here. Here I solve for h squared as well. So I was allowed to take that 13 squared minus x squared and replace it for that h squared, which is what I have up here. I have 13 squared minus x squared equals 15 squared minus 14 minus x squared. I solved it. Turned out x equaled 5, which got me my base, and it also got me my height. Because my height just equaled 13 squared minus x squared, so if that's 5, I could solve for h, which I did there. And our area equaled 204. Yes?
On this one, could you isolate x instead, so you
Yep.
just get
Yep.
h right away?
Mm-hmm. Like I said, as soon as you have your two equations, you just need to find a way to solve it, elimination or substitution. Substitution, you could have solved for x, and then set them equal to each other with h's. And you would have solved all the way down, and you would have got h equals 12, and you would have plugged that back. Grant, do you have any specific questions? I just don't want to spend. Okay. Let's talk about 27, because it's probably also a question. It says that we have a trapezoid with area of 100 centimeters squared, has bases 5 and 15. Find the area of the two triangles formed by extending the legs until they intersect. So our trapezoid is right here. That is my trapezoid. And the triangle they're talking about is extending the lines until they make points up there, which creates two triangles. It creates an upper triangle, and it also creates a big triangle here. Well, in order to get the area of either one of those, I have the bases of both of them. I just need to get the height of both of them. So I need to get this full height, and I need to get this little section right here. Well, this full height, I know part of it, because it did say the area of the trapezoid was 100. So to get this h here, I just used the formula that the fact that the area of 100 equals 1/2 height times our base 1, which is 15, plus 15. I solved for that, and I got my h equals 10. Then you had to realize that they were similar triangles. This green triangle is similar to this blue triangle. And we could have used angle to prove that. I'm not worried about proving it right now. What I am important about similar triangles is they have a ratio between their sides. The ratio from that small blue one to this big green one would be their bases, 5 to 15. In other words, 5 over 15. So that means the ratio is going to hold for all their parts. Well, the full height of this green triangle would be x plus 10. The height of the small triangle would just be x. So the ratio between x plus 10 and x is going to be the ratio between them. So that's why I set up that x over x plus 10 equals their ratio of 5 over 15. Then all you had to do is solve for x, and basically the whole problem's solved from there. Because as soon as you know x, you know the total length is 5 plus 10, and the little one is 5. All right. Yes?
26.
Number 26. Say that again. I'm sorry.
I am putting 24 for the area.
Okay. Let's see where we differed. Oh, did I not finish 26? Oh, no, I got it. No, we're okay. Oh, did I use the original numbers? Just a second. So I had this, did I not have 6, 8, and 5 for yours? Okay, so you have the original, so you must have had an old document. Well, the original one would have been the answer from our notes. It would have been the same problem as the notes. Whatever we had for a solution for the notes would have been the same solution there. Sorry about that. Yep. I meant to change them so it wouldn't be the same one as the notes. But, oops. Hands up.
For number 21, is it okay if you got 87 instead of 87.7?
Yes. Other questions? Before I get started, just in case I run out of time, remember test corrections are due on Friday. They're due on Friday. I don't remember who has test corrections all in here, but I have not seen anyone yet. And I know there was a couple people that needed to do test corrections. That is due Friday. I will not extend that date because no one came and talked to me earlier. So Friday when I leave, that is it. All right. Area of regular polygon. Area of regular polygon. We can actually find the area of regular polygon without knowing any formulas or anything. It is almost the same thing as when I asked for that rectangle that was inscribed in a circle. We can figure stuff out by creating shapes that I know the areas of. So for example, if I was doing the area of a regular polygon, I know we don't have any numbers on there, but my first thought would be, let's make this not that big of a line, first of all. Let's make this into triangles. Because I can find the area of triangles. In fact, I would separate it into all these triangles. Well, each of those triangles must have the same area. And how many triangles do I have? I have 6 triangles. Well, note that, so a hexagon has a number of sides being 6. So our number of sides equals 6. So the number of triangles is also 6. So the number of sides is how much you're going to multiply by. So if I wanted to find this area, I know I don't have any numbers, but I know how to find the area of a triangle. The area of a triangle is going to be 1/2 base times height, where a height would be this little guy that you drop down here and make a right angle. Bless you. That means at a total generic level, a regular polygon's area, its area is going to equal the area of the triangle times, and we have the number of triangles is the same as the number of sides, so it'll just be times the number of sides. So generically, we have area of a triangle times the number of sides equals a polygon. Well, that's exactly what the formula is. That is exactly what you need to know for the regular polygon. So let's refine this a little bit. Well, the area of a triangle is actually 1/2 of base times height, and we'll still go with number of sides. Well, let's take a second and look down here. We're going to put some terms next to it because we don't talk about things in base and height in terms of a polygon. Instead, let's break that one into a triangle and talk about the key parts of it. I'm going to draw my little dashed line going down the middle. And we're going to say the important names behind this. In fact, I'm going to start with that dashed line I just drew. This is not the height of your polygon. Your height of your polygon would go all the way up. In fact, that's 1/2 the height of the polygon. That has a very specific name with polygons. It is going to be called an apothem. It's almost like you can't say opossum. It is an apothem. Apothem is 1/2 your height of your polygon. So without problems, I will just strictly say this is your apothem. Well, those two little things forming this are our radius. That will stick with that term. It will be the radius of a polygon. The radius of a polygon is that length that goes from the center to an angle of your polygon. That is known as your radius. The other thing I'm going to say is really important is this angle right here. That angle right there is the central angle. But more importantly, we actually know the measure of that angle. Does anyone think they remember the measure of that angle or how to find it? Hamza.
Isn't it just n minus 2 times 180 and then you divide that by 6?
That would give me this angle. I'm looking for that central angle. Yeah,
60.
it is 60. How'd you get that?
Because the whole, or if you like draw those two triangles all around is 360.
Yep.
Divide that by 60.
Perfect. If you go, a full circle is 360. Well, 360 has to be broken up into 1, 2, 3, 4, 5, 6 equal angles. So we do 360 divided by our number of sides to get that central angle. So our central angle is going to equal 360 divided by n, where n is our number of sides. Now the other thing I'm going to note is the base. We don't call it the base. We call this the side length. So although a lot of times we'll have the area equals 1/2 base times height, recall that your base is actually your side length, and your height is going to be called an apothem. It's not terribly important if you were just given a picture and you have to pick that stuff out. But if I give you a problem that say the side length is 12 and the apothem is 8, you have to know where it goes in the equation. So the area of a regular polygon is as stated like this, but you should really think of it as being 1/2 your side length times your height times your number of sides. Instead of height, I should have said apothem. So 1/2 your side length times your apothem times your number of sides. We're going to get one more formula, and you need to know this formula. It is based upon this formula, but it's slightly different. Look at this base times number of sides. Base times number of sides. Like if I have a square, and I have a side length of 4, and I do 4 times 4 is 16, your length times your number of sides is actually your perimeter. So another formula for regular polygons that you have to know is area is also going to equal 1/2 your apothem times your perimeter. So two equations. First equation, 1/2 your side length times your apothem times your number of sides. Our second one is 1/2 your apothem times your perimeter. Got to know these formulas, guys. Test is on Monday, and if you don't know the formulas, you're going to tank this test. Yes?
Do we know why that is? Or?
It's because side length times number of sides equals perimeter.
Oh
Yeah.
yeah.
So I'm just condensing it down. Kind of like our median one from yesterday, where we said our median was actually half of base 1 plus base 2, so we could just call it the median.
Yeah.
Same thing here. I'm just calling B times number of sides my perimeter. So in fact, if you want to in your notes put that in there, that, well, perimeter is really your base times your number of sides equals your perimeter. So I didn't really change the formula. I just edited it in case for homework. On problems, I might just say what the perimeter is. And rather than having to find out what your number of sides are and stuff, just use your perimeter. All right, let's go through some problems in a fast pace. All right, a regular hexagon has sides 7 meters and an apothem of 5.2. What is the area? Well, there's 3 things we need to find area. Remember, area equals 1/2 your side length times your apothem times your number of sides. So you just need 3 things. You need a side length, you need an apothem, and you need a number of sides. Several of these problems will have all of that included for you. You just have to know where to plug it in. Well, in this case, we have side lengths. It says that it has sides of 7 centimeters. So our side length is going to be that 7 centimeters. We also have an apothem. It says the apothem is 5.2, so we're going to take that 5.2, plug it in for there. The good thing is most of the time we know our side lengths because it gives us, or our number of sides, because it gives us our name. How many sides does a hexagon have? Yes. It is 6 sides. A hexagon has 6 sides. Maybe I should do it in blue like I did over here. This is 6 sides. So we're going to multiply this whole thing by 6. And then our total area will be 109.2 centimeters squared. Polygon. Side length, apothem, number of sides, and you are done. You have an area. Yes?
So you don't have to draw, do you?
Nope. All right, next one says, find the area of a regular hexagon with radius of 6 square root of 3. This is definitely one you would need to draw, though. So if you can't, so Cam, I guess the reason why I didn't have to draw this one is because I knew I had all 3 bits of information. I didn't need to draw it to figure out what it meant. In this case, I do have to draw what it means because they just gave me a radius of 6 square root of 3. They did give me 6 sides, though. So just remember your area equals 1/2 your side length times your apothem times your number of sides. Well, we have our number of sides. That is really all they gave us was our number of sides. Next thing they gave us was our radius. Our radius really has nothing to do with our formula. The radius will just get us to the 2 facts I need. I need an apothem, and I need to get the side length. In order to get our apothem and our side length, we're going to do the exact same thing. We're going to draw our triangle. So we're going to draw our triangle just like that. That has a radius of 6 square root of 3. And this is 6 square root of 3. What's the measure of this central angle? Yeah.
It's 60.
It's 60 degrees. It's the same one as the one before. We can do the side work also. We could say, well, that angle is going to be 360 divided by, I should have had more room, divided by number of sides, which is 6 sides, is going to equal 60 degrees. That actually makes all of these 60, but that's not a big important fact, although it kind of is. If all of these are 60, what do we know about all 3 of the sides? Yeah, they're all the same. So we actually know our side length is 6 square root of 3 right now. I'm going to go a different way about it. So right now we actually know that it would be 6 square root of 3. But I'm going to find it while I find the apothem too. Our apothem is that line that cuts that triangle right in half. So let's go ahead and draw that triangle down below that I just created. So that triangle is going to be this guy. I should have had the bottom. All right, nope. So I got this sweet triangle right here, kind of terribly, but we got it, which we have a 6 square root of 3. Note that the central angle is 60. So this angle right here will not be 60, it will be 30 degrees. It will be half. I'm splitting this angle in half. So each of those are going to be 30 degrees. So this is going to be my 30 degrees. And this will be my 60 degrees right here. So once again, it splits it into a 30 and 30 degree. All right, so I have a 30, 60, 90 triangle. Awesome. That's something I can solve. Since we have 6 square root of 3, the one across from our 90 degrees is our 2s. The one across from our 60 degrees is our s square root of 3. And the one across from our 30 degrees is going to be just our s. All right, let's do a little scratch work. I think most of you can probably crush through this stuff now, but 2s would equal 6 square root of 3, so s just equals 3 square root of 3. Which means our s square root of 3 would equal, plugging that 3 square root of 3 in place of that s. We would have 3 square root of 3 times square root of 3. Well, square root of 3 times square root of 3 is 3. 3 times 3 is just 9. So that 9 is actually that right there, which is also our apothem. That is our apothem. So if I drew that full triangle, since I'm kind of running out of room, I'm just going to draw it over here. If I drew that full triangle that we just had there, and I drew my dashed little line down here, we would know that that red line is 9. We would know this base is 3 square root of 3, 3 square root of 3, but we already knew this total length was 6 square root of 3. And that's all the information I needed. I needed my side length, which is 6 square root of 3, and I needed my apothem, which is 9. That's all the information I needed. So our area now equals 1/2. Our side length is that 6 square root of 3. Our apothem is 9. And our number of sides is 6. Did anyone get ahead of me and do that multiplication? Or can you now, so I can get it? Yeah, Isabel.
162
Radical 3. Can anyone else confer that that is correct? Before I move on, I always wait till 2 people come up with it. Yes, we're good? Okay. All right, so our end answer is 162 square root of 3. So our whole goal in this one was to create a right triangle to find our height. The good thing is I actually already knew my base was 6 square root of 3 because it was a 60, 60, 60 triangle. And here's some advice for your future. In order to do a problem like this, I need it to be a 60, 30, 90 triangle. In order for me to make something that's going to work with a 60, 30, 90 triangle, most of the time, I'm going to give you a hexagon on this type of problem. The good thing about a hexagon, you will know that this is 60 degrees, and you will know that the base is the same as there. In other words, we have equilateral triangles. Because it's 360 divided by 6, so it is, let's see to go back to it. We have 360 degrees to spread out between all these triangles. You just have to count how many angles there are. So in this case, there's 1, 2, 3, 4, 5, 6 of them. If there was 8 sides, we'd have 8 triangles we can make. So it'd be 360 divided by 8 would give me that central angle. Just know your central angle has to be 360 divided by your number of sides. Because it's a regular polygon. It wouldn't work for all polygons, but regular polygons will work. So if it's 12 sides, it'd just be 360 divided by 12 would get you that central angle. All right, 2 more quick ones. Ugh. All right, a regular polygon has a perimeter of 112 and an apothem of 7. What is our area? This would be one that you would want to know that area formula that works with perimeter. Well, area equals 1/2 your apothem times your perimeter. So if I knew that formula in the test, I would just simply go, okay, 1/2 my apothem is 7. My perimeter is 112. And that's going to result in 392 centimeters squared. So that's going to be the difference between an easy problem and a hard problem. If you didn't know that is times perimeter, you're going to have to start looking at what is it, how many sides do I have, what are the length of each sides, and you're going to create a very difficult problem for you. So know that formula. All right, the last one says a regular hexagon has a perimeter of 216 centimeters. What is the area? If I know the perimeter, I just need to find the apothem. I just need the apothem. So once again, our area equals 1/2 our apothem times our perimeter. We already have our perimeter, so we just need to find our apothem. Finding our apothem is going to be that exact same way where we draw our regular hexagon. I guess I wrote that pretty tiny, but that's okay. We have a perimeter of 216. So what's the side length of every one of those lengths? What is the side length of each of those? Yeah, 36. So that's 36, that's 36, that's 36, that's 36, that's 36, that's 36. We're going to draw our triangle. We need to know that a hexagon has a central angle of 60 degrees. We could do our 360 divided by 6, which comes out to 60. But it really is the same problem as above. Our apothem is going to be that line right there. It is that red line right there. That is my apothem. In order to solve for that apothem, we're going to draw it. So I'm pulling out that triangle, making our right angle. Well, if this whole length is 36, then half fit's going to be 18. I'm looking for that height. And my central angle is 60, so that top angle is actually just going to be 30 degrees. That bottom right one would be my 60 degrees. All right, the one that's across from our 30 degrees is our S. So our S equals 18. Our apothem, or our height, is going to be our S square root of 3. That is the one across from 60. Well, we already said that S equals 18, so that means S squared of 3 would equal 18 square root of 3. And that 18 squared of 3 is my height, which is also known as my apothem. So that means my area is going to equal 1/2 my apothem. In this case, we have 18 square root of 3 times our perimeter, which is 216 centimeters. Our total area should end up being 392. Nope, scratch that. Correct me if I'm wrong, because I have this kind of in the wrong place. Is it 1944 square root of 3? All right, cool. Centimeters squared. I do want to say it looks like a lot of work, but it's kind of the same problem every single time if I give you a radius or something. It is just drawing this triangle, getting a 60, 30, 90, and solving that 60, 30, 90 for your apothem and possibly for your base. That is as hard as those problems really become. All right, we do have an additional problem, and I should have time to go through this one just barely. You have 3 problems at the end. We are going to determine the area bounded by the x, y, and each line. So the first thing we have to talk about is how to graph a line. So both of these lines are in slope-intercept form, and on the homework it'll also be in slope-intercept form. Remember, with slope-intercept form, it's y equals mx plus b, where your m is your slope, which is your rise over run. And that b value is going to be your y-intercept. In this case, if our y-intercept, our x would be 0, so it'd be 0, b. When you graph lines in slope-intercept form, you need to find your intercept first, and then use your slope to find your points to draw the rest of your lines. So let's look at that first one. That first one is y equals negative 1/2 x plus 6. That plus 6 is our y-intercept. So that's going to be the point 0, 6. 0, 6 is right here. In other words, you find this along your y-axis and you put a point there. If this was 8, I'd find 8 and I'd put a point at 8. It's at 6. All right, our slope is now negative 1/2. That is our slope. How do I use negative 1/2 to graph this line? So I have my intercept. Now how do I get to the next thing where I put it down? Yes?
To the left 1 down 2.
Slightly different, yes. Down 1, right. So it's rise over run. So your top one's your up or down, and your other one is left or right. So because it's negative, negative tells me to go down 1 and to the right 2. So we go down 1 to the right 2. I should stick with purple. Then I go down 1, right 2, down 1, right 2. But that should be enough for me to come up with my line. All right, that's my first line. My second line, be careful on your second line. See this negative 3? That whole negative 3 is your y-intercept. So that's going to be the point 0, negative 3. In other words, you're going to find negative 3 on your y-axis, and you're going to put a point there. So it's all that whole negative 3. Our slope in this case is 1. So our slope equals 1. Well, that's hard to do rise over run because it's just 1. Always think of it as a fraction. Instead of 1, I'm thinking 1 over 1. Is that what you're going to tell me? Sorry. It's 1 over 1. So we're going to go up 1 over 1. Up 1 over 1. Up 1 over 1. I don't want all those on there. Up 1 over 1. And then we can draw our line. All right, now let's look what the direction says. I need to determine the area bounded by the x and y axis and each line. Your lines are going to form a triangle. So let me talk about what we're saying here. So it's saying, look at this line and this line, the x-axis and the y-axis. So I want to find that area there. That is defined by our line, upper line, lower line, x-axis, y-axis. So that's the area I'm looking for. I'm going to highlight that a little bit lighter because I want that on there still. So I want this area here. Well, here's the problem. I can't necessarily just find that area directly. Instead, what I'm going to do is I'm going to notice, do we see this really big triangle right here? I'm going to find that area of that really big triangle. So let me highlight that in yellow. So I'm going to find the area of this triangle here. So that'll be my big triangle. Let's call that area B, is the area of our big triangle. Well, area is always 1/2 base times height. Well, if you look at this triangle sideways, if this is my base of my triangle, then this would be my height of that triangle. So that's exactly what I'm going to look at. So let's mark that up. So first of all, this is going to be the height of the triangle. And height would equal 1, 2, 3, 4, 5, 6. And the base of the big triangle, so basically from here all the way down here, that would be the base, would be 1, 2, 3, 4, 5, 6, 7, 8, 9. So the area of the big triangle is going to be 1/2 6 times 9. Well, that means the area of the big one is 3 times 9, which is 27. But note, I found this entire area here. I don't want all that area. I want to get rid of this bottom little triangle right here. So if we look at that little triangle right there, well, that has a height of 1, 2, 3, and a base of 1, 2, 3 also. So the area of this little guy, let's call it area small of my small triangle, is going to equal 1/2 3 times 3, which is going to equal 9/2. So now how do I find my actual area? The area I'm looking for, Leanne?
You subtract the big area minus the small.
Yep, big area minus that small stuff I don't want anymore. So that's going to be 27 minus, instead of 9 over 2, I'm just going to change that to 4.5, which would equal 22.5. All right, you do have 2 problems like that. We went through a lot of hard problems